Alright, in this particular equation we want to start by looking at a couple situations where we need to use the distributive property. Over on the left side we've got 2 times the x plus 1, and then on the right side 3 times the x minus 1. So to start on the left side here, 2 times x will give us 2x, and 2 times 1 will give us 2, plus the 3. On the right side we have 3 times x, which is 3x, minus 3 times 1, which is 3. Back over on the left side we have a little bit of simplifying we can do with the plus 2 plus 3, so we could simplify that to 2x plus 5. And then on the right side we still have 3x minus 3. Then we can start to make some of our typical legal moves. One option we can use is to subtract or remove 2 x's from each side. That'll leave us with 5 on the left and an x minus 3 on the right. The next move we can make would be probably to want to get rid of the negative 3 by adding 3, so we get x by itself, and then adding 3 to the other side to create a matching set there. So as a result we have 8 equals x, and actually there is our solution. We want to verify that that 8 is correct by substituting or replacing it in that original equation we started with. So over here on the left side we're going to plug in the 8 where we had an x in parentheses, and then an 8 where we had an x in the parentheses on the right side. And we want to make sure that both sides are equal to each other. On the left side we're going to have 8 plus 1, which is 9 in the parentheses, times the 2, which is 18. And then if we add 3, we're going to have 21. On the right side, we're going to have 8 minus 1 in parentheses, which is 7. 3 times the 7 will give us 21. So that's verification that our solution to the equation is that x is 8. For our next equation, again we have an example of needing to use the distributive property on the right side. 3 times the negative x plus 2. So 3 times the negative x would be 3 negative x's plus 3 times 2, 6. Still have negative 2x minus 2 on the left side. Next thing we want to take a look at is trying to remove some possible matching sets. You may notice that we have 2 negative x's that we could remove on each side. So we can subtract 2 negative x's on the left, subtract 2 negative x's on the right. That'll leave us with the negative 2 on the left, a negative x, and then the 6 on the right. Next thing we probably want to do here is to try to get the x by itself. So if we want to counteract the positive 6 by adding a negative 6 here, and then doing that to both sides to create a matching set there, we're left with negative x equals negative 8. Well, we always want to put x in terms of it's positive, not a negative. So if a negative x equals negative 8, then we can state that a positive x equals a positive 8. Again, we want to verify that that solution is correct. So if we replace it and plug it back into that original equation where we had x's, on the left side we'll have negative 2 times 8 minus 2. And on the right we'll have 3 times the negative 8 plus 2. So on the left, if we simplify that, we'll have negative 2 times 8, which is negative 16, minus the 2 is negative 18. And on the right, we'll have negative 8 plus 2 in the parentheses, so that's negative 6. 3 times negative 6 also gives us negative 18. Again, we have verification that that solution is correct.